Hello everyone, welcome to this video. Our chapter is waves, and we're still discussing about the waves. So let's move on to the other part today, whereby we'll be discussing about the classification of the waves. Uh, so far in our previous video, we've classified the waves, but let's see the other types of waves. And in detail, we said that previously we classified the waves by considering the movement of the particles. So we considered the movement of particles and we classified the waves. Now today in this video we're going to see uh, you can classify the waves according to the media of propagation. So we see the media of propagation that carries out the wave. You can simply classify that kind of a wave. Now from there we have two of them. The first one is the mechanical wave and the second one is the electromagnetic wave. So there are two kinds of waves according to the media of propagation, the mechanical waves and the electromagnetic waves. Now let's discuss one by one each one of them, starting with the first one, mechanical waves. The mechanical waves are also called the elastic waves, as they are as their propagation just depends on the elastic properties of the medium to which the wave passes. So this is the first kind of wave, whereby it is just like elastic wave, as thereby the propagation it just depends on the elastic properties of the medium through which the wave is traveling or the wave which it is passing. Now, the mechanical waves are divided into three categories. There is the transverse waves, the longitudinal waves, and the surface waves. So far in our previous video, we discussed the transverse waves and the longitudinal waves. So both all these three all of them three are just the mechanical waves. Now, in terms of vessel waves, the medium moves perpendicular to the wave direction, and the longitudinal waves, the medium moves parallel to the wave direction. We said that before. Now, in surface waves, just both the transverse and the longitudinal mix in the single medium. So the surface just mixes up all these two, the all of them to just to make one of kind of a wave. Now, in a very simple ways, an electronic wave is that which travels in a vacuum, and a mechanical wave is that which needs some medium for traveling. So, electromagnetic wave, which we'll see later on, so they can be differed from the mechanical waves in that kind of a way. Take an example of the mechanical waves. We are talking about the sound waves, the water waves, the ocean waves, the earthquake waves, the seismic waves. All these are just examples of the mechanical waves. Moving on, let's see the electromagnetic waves. The electromagnetic waves, these are waves that have no medium to travel, whereas the mechanical waves, they need medium for its transmission. So these electromagnetic waves, they just don't require kind of mediums. Take an example like water, etc., from the mechanical waves. So they just don't require such kind of mediums. Examples of electromagnetic waves here, we're talking about the light, the X-ray, the gamma rays, and the radio signals. All these are just the electromagnetic waves. Therefore, just the differences are just few depending. Based on these two, the mechanical and the electromagnetic waves. The electromagnetic waves they travel in vacuum, whereas the mechanical waves they do not. They just require some kind of a medium to travel through. So that's the first difference. So the mechanical waves they just need a medium like water, air, or anything. Just from there, just to travel from one place to another. While the electromagnetic waves is just called a disturbance. A mechanical waves is considered a periodic disturbance. So this is the other kind of differentiation between these two, electromagnetic wave and the mechanical wave. So that's all I have for this session of the scale. We've briefly seen the two types of waves based or just according to their propagation. And we've seen that there are mechanical waves and the electromagnetic waves. I hope that's all clear. Thank you.